Hello and a warm welcome on Wednesday morning here at the public forum from the Hydrogen Fuel Cells Europe at the Hannover Fair 2022. I'm excited to start the day here in the public forum. We have an interesting topic to talk about the upcoming 20 minutes. So join us here, have a seat, grab a coffee. I know it's still early, so sit down and enjoy the talk and listen to what we're gonna talk about. We talk about from plate to process to plant, metallic bipolar plates for fuel cells, how to choose the right production technology. Please welcome on stage the Managing Director from Gräbener Maschinentechnik, Fabian Kapp. Thank you for being here this morning.
Good morning.
Good morning. So let's start with an easy question. What is your company doing?
Oh, good question. So our company is doing a lot. We are a traditional machine building company, 100 years old. We are coming out of the bending and milling technology, mainly for heavy wall thickness plates manufacturing. But 20 years ago, we started with having a focus on production technology for metallic bipolar plates. And so we are a specialist for production technology to produce bipolar plates and the surrounding necessities.
So more than 100 years, more than 20 years in the field of bipolar plates. So you already mentioned the production technology. Can you maybe dig a bit deeper? What is exactly the production technology that you're using and what are the possibilities that you offer?
Yeah, for sure. So we are a specialist for hydroforming technology. It means if you have a look for the forming of the bipolar plate, it is not a mechanical stamping process, so we are using water in our machines. It means at the end we have a very gentle forming process, a very high quality in the forming process. We can produce very high accuracy in the blades. And beyond the forming technology, we are also a specialist for the topic of cutting the blades in the final shape. Then we are also providing the technology for the welding of the single blade so that you will get the bipolar blade itself. And so at the end, we have to focus from the coil to the finished welded bipolar blade, which needs then to be put through the next steps like the maybe post-coating topic, maybe the sealing technology, etc. But for that topics, we have a partner network who can then provide the needed machine technology.
Okay, so when it comes to the plate, it's kind of end-to-end for the process, as we say, from plate to process to plant.
Right.
Okay.
Right. So especially when we are talking from plate to process to plant, our specialty is not only providing the machine technology itself, we have also an application lab in our company. So we have a very detailed discussion with our customers before we start developing the machine technology. So in the first step, we normally have a discussion about the design of the blade so that we are able, or that we need to check the design itself. We need to know what kind of material should be used. Then we will do a very deep analysis of the geometry itself so that we can figure out what is possible in regards to the manufacturing technology, what needs maybe to be changed in our machine technology. We need to develop the tooling for the production. And so there's a lot to do before we start having a look on the machine technology. This also means we have a lot of discussion what the customer wants to have and what we are able to provide by the limit of physics. And so we are using also the application lab to do some trials in regards to forming or also welding. So it means before you start with a very big blade, you can start with a very small test tool where we can verify all the process parameters, where we can verify the final geometry so that the customer will be also satisfied with the results. And then we will go into the next stage that we can design the blade as a final 3D model and then going the next step from the prototyping so that the customer will prove our production technology in our company. Also, we are able to provide maybe a couple of thousand produced blades so that they can build up a test system, some references, etc. And then our focus is to see how we can define the process from the existing blade then to the process or production technology in total. This also means the discussion about volumes needs to be produced, so how we are able to do the transformation from a couple of thousand blades to maybe a couple of million blades with our production technology.
Okay, so you always start with the prototyping, a lot of discussion. Sounds really customized.
Yes, definitely.
So it's very individual.
Yeah. What we see is, we call it that every blade is like a fingerprint from our customer side, so there's not a one-for-all machinery solution, because every blade is so different that it is, from our point of view, not possible to build this one machine which could be used for all kind of blades. Blades have different dimensions. This is very important, especially for the hydroforming process, because the dimension of the machine is related to the size of the blade. And then if we go through the next steps, especially the welding process, you have very different designs from the customers in regards to maybe welding levels, so the height in the blade, what areas needs to be welded. And so this is so complicated that the machine needs to be specified for the blade, or maybe a couple of different variations from a blade. But fitting every blade in one machine is not possible.
Okay. So can you maybe say a bit about the time frame? You mentioned the different process steps from prototyping to value proposition. Yeah. How long does it usually take, or an average? I guess it's individual, but still.
Yeah, definitely. So in average, we can say that if we start with the design stage, so maybe we have now a design freeze, it means we are clear with the customer what should be the final design, which needs to be produced. Then we are talking normally about 3 to 4 months until the customer will get the first blades from our company. And then for sure, if the customer is looking for getting the machine technology itself, at the moment it is very difficult in regards to the delivery time, because material, getting the steel for the machine, getting simple components like PLC controls, it's very difficult. So the lead time for the machine itself, it's hard to predict how long it is then at the end of the day.
Okay, so it's a step-by-step process that you have to be convinced that this is like how we want to go forward. Yes.
The longest discussion, or the longest time which will gone by, is the discussion with the customer to get the design from the customer, because we need to see the design. For sure, the 3D data is the most beneficial for us, so that we can make a real deep analysis of the blade itself. But getting this information is very difficult, because everybody is making a very big secret around their blades. They are not willing directly to give out the details. For sure, we have NDAs, etc., but it is a very hard task to convince the customers that their IP is safe in our house. We don't use the IP for any other interest or clients, so that we really can focus on the needs from the customer.
Okay, so it's really customized for the customer, what he needs. Then here at the fair at the moment, everybody's talking about scaling up the business. Yeah. How is this affecting your business? How do you approach the topic of scaling up?
Yeah, a very interesting question. So we are 20 years in the market. We have seen many different phases in the fuel cell or also electrolyzer industry. There had been phases where customers wanted to have a production technology for 150 million bipolar blades a year, which is a lot if you have a look to the market. So nowadays we are back in a stage where we are talking about production volumes from maybe 5 million bipolar blades per customer per year. This seems to be realistic, but still this is nothing which will happen tomorrow, but maybe in 2, 3 or 4 years. So, and for that matter, we have a scalable technology. That means as we have a flexible constellation from the machines, we can start with a low volume production, maybe also only the core machines for bending, welding and cutting, but no automated handling. So no transportation system, etc. So it means you have very low investment costs for the technology, but you need to do everything manual between the processes. This is still possible for a couple of 100,000 blades a year, and then you can increase time by time in regards to your production volume, what you like to get, with the investment in more machine technology. And for that matter, our technology is designed that you don't have to spend exactly the same money for the next machine. For example, the hydroforming machines, you can buy the first machine, which is able to produce around about 5 million half blades a year. If you will buy the second machine will be cheaper because the second machine can use the technology like the water technology and the hydraulic unit from the first machine. And this is where we have to focus to find the best economical solution for the customer.
Okay, so it gets price-wise, it gets cheaper
Yes.
when you're scaling up. Okay.
Right.
I see some more people coming in, so please have a seat. You can get a coffee here. Maybe I open up the round for a moment. Are there any questions already from the audience? Okay.
You are providing basically the technology to manufacture bipolar plates. Are you also interested to produce your own design? And will you go in competition to your customers?
No, definitely not. So we are a machine building company. Our DNA is the engineering, so we like to have difficult tasks to solve for the customers. And for sure, we have nothing in mind to produce our own blade. We also have no capacities in-house to make a functional design of a blade. We have the specialists who are able to do the analysis of a bipolar blade, but still the design for the functionality must be done by the customer or an institute or somebody else, and this is where we are focusing also for the future.
Thank you very much for this question. I think it's also difficult because you mentioned in the beginning that you are a trusted partner and it's hard to get the informations from the clients. I guess it will be a conflict of interests if you would start to do your own.
Definitely, definitely. If we would go the way and say, okay, we now wanted to produce our own design, then you also need to think, okay, what we will do with the design, because then you need to start with the development of the stack, then you need to do the sales for the stack, so you will be a real stack producing company, and so there is no interest for us in making our own design for a blade which can be used for bipolar blades or fuel cell stacks or electrolyzers.
Okay, so you're in the market, or in the hydrogen market on fuel cells of more than 20 years. What kind of challenges do you see in the market?
A lot. First of all, the price is for sure always a discussion. And what we see nowadays is that the automotive industry has at the moment the focus on the battery technology. So the fuel cell is reduced at that point. We see a lot of interest from the aircraft business, airplanes, etc., military applications. So there the price is not the hard limit or factor at the end. But also a very big challenge is for sure then the infrastructure. So we are talking about fuel cells and electrolyzers. On the one hand, we need to have the electrolyzers to produce the hydrogen, but then the question is how to bring the hydrogen around the world. So you need to have the infrastructure that then the fuel cell will have also the benefit at the end of the day to use the hydrogen and produce the electric power. So this is a very hard task. And for sure, again, the topic with the limitations in regard to the NDA, sharing details. My wish is that, especially to a trusted family-owned company, there would be more openness for the discussion, because we have proven in the last 20 years that we don't go out with the details to anybody else.
You just mentioned that you're a family-owned company. In the business, you're also from Germany, from a part where it's maybe also hard to find good people. We've talked about it. War for talents is also a topic for you.
Yeah, definitely. So we are located in a very landside region, I need to say. I guess in general it is public known that it is difficult to find people for different kind of technologies in the industry, but if you are going now also in a topic which is then specialized moreover and with the view on the fuel cells or electrolyzers, finding the right people is a very, very hard task. So last year we got lucky that we find a very young guy He's from the Iran. We got him from the university in Aachen. He's very interested, but finding people like him, it is more like a lucky shot to get this one people. Because in our region, it is a classical automotive supply region, very traditional machine building companies. There's nobody who has real knowledge in regards to fuel cell technology, and bringing the people to that point is very, very difficult. And what we see is that more and more interest is in the market, especially now, also during the war in the Ukraine, that the electrolyzer is more and more interesting because the hydrogen is needed for the future. So the topic in regards to the talents will be more and more difficult for the future.
It's interesting because it's the first time I've heard it this year that the war for talents is a big challenge, especially in this field, because we have on the one hand the war for talents in general happening, but then with the new technology where there is still not so many students coming out of the universities that are trained. So I think it's really a big topic at the moment.
Definitely. If you have a look into Germany, also in the landscape of universities and institutes, there are not so many institutes and universities who are able to train the people that they are able to gain the knowledge and then to help the industry to expand the business. So I guess this is a general public problem which also needs to be solved by the politicians, that also the universities have more focus on new technology or new topics like this.
Yeah, it's at the World Economic Forum in Davos in 2020. They also announced the reskilling revolution worldwide, because it's really a big topic that the whole, like everybody needs to be reskilled in new directions where the world is turning. So back to your company, where do you see the future? What are your next steps? What are you working on?
Yeah, so definitely, as I said, we have a more traditional business side with production technology for the heavy steel industry. If I have a look in that business, for the future we see that this will decreasing business, because it is very hard to fight against our competitors from all around the world. So the price is also very hard in regard to the sales for our classical machine technology. And on the other hand, we see the new technology coming up. So we see a transition in our company in regards to the new possibilities with the fuel cells and electrolyzers. And 25 years ago, we had been a production company for big steel pipes. So we hadn't been a machine building company. But 25 years ago, we saw the need that something needs to be changed. Otherwise, there wouldn't be, or there haven't been a future for our company at the end. So, and I see us right now at not the exactly same point, but still there is something we need to do, that our company will also fight the future and we don't fall back. Let me say like this.
So it's really interesting times ahead where you're heading with the company. I also like it to think sustainable. Okay, we have to change or develop ourselves to stay relevant in the future. And I wish you best of luck for this.
Thank you.
Thank you so much for being here today and spending your time, your morning with us here at the Public Forum.
Was a
Thank
pleasure
you very
for
much,
me.
Fabian Kapp.
Thank you.
So if you want to talk with Fabian Kapp further about the topic, you can also find him at booth C241 or right after the interview when he steps down the stage.